Okay, let's go ahead and solve another problem. This one having to do with um, proportions. So let's go ahead and look at the problem text. It says, use a given degree of confidence and sample data to construct a confidence interval for the population proportion. So we want to create a confidence interval. All right, so I think what we need to do, we're going to go ahead and try to do this in two different ways. The first way is using a formula. So the formula is going to be p hat plus or minus z alpha over 2 over the square root of p times q over n, where q is this p hat, q hat, where q hat is 1 minus p hat. Okay, so then the first thing we need to figure out is what is z alpha over 2. And so you have to think of the margin of errors being distributed over a normal distribution. And we want to find a 95% confidence interval. That means that 95% or 0.95 of the errors are going to be in this area. That means that we have 2.5% over here and 2.5% over here. And so what we need are the z alpha over 2, z alpha over 2. Now this one's going to be negative, this one's going to be positive. So we're actually going to go with this one because the negative is already taken care of over here. But that means that if I look at this area over here, instead of thinking about the 95, we actually are looking at 97.5 because the other 2.5% is here. And of course, we want to convert that to decimal 0.975. Okay, so we'll go ahead and bring up the calculator to figure out what that is. Go ahead and clear this. And we're going to go to a distribution. And we're going to go to inverse normal because that's going to allow me to give a 0.975. And the mu is 0, sigma is 1, leave that alone. Okay. And that gives me a 1.96. Okay, let me go back. So this is going to be 1.96. So using the formula over here, p hat is 30 over 56. Let me compute that very quickly here. 30 over 56. That's 0.536. That means Q hat is 0.464. And so the confidence interval is going to be 0.536 minus 1.96 times the square root of 0.536 times 0.464. I'm kind of running out of space here. All over n, which is 56. Okay. And just for space, let me do the rest kind of down here. Hopefully it'll make sense. But it's 0.536 plus 1.96 square root of 0.536 times 0.464 over 56. I know the handwriting isn't great. All right, now you would compute that. And what you should end up with is the same thing, doing it that way, as if you were doing it this way. I would think you'll like even better. What we're going to do is a one prop z interval. Now, the x, if I recall correctly, is 30. And this is going to be 56. And you leave the confidence level in this case as is. You don't have to do anything. I believe it was 95. And you calculate it. And let's try that again. This is supposed to be 56. Let me just double check that value. Yes, it's 56. And there's a confidence interval. So the 0.405 and the 0.666 should be identical to the computation you made. So even though this is coming from the calculator, you should get the same answer, and it's 0.405 and 0.666. Okay, and that's how you do these problems.